Hello, my mathematicians. This is Miss Foster with Math in Focus, 3rd grade, Chapter 14 on fractions, Lessons 2 and 3 together. We're going to be talking about how we can find lots of equivalent fractions and simplifying fractions. And I'm excited, so let's go right to it. So this may be a review from 2nd grade. I don't actually know yet, but equivalent fractions are modeled right down here. They're fractions that represent the same amount of stuff, whatever stuff you're thinking about, but in different size pieces. So you can see down here, if this is one whole, and that could be a whole yard of fabric, it could be a whole skein of yarn, it could be a whole bag of chocolate chips, I don't know. We can see that if we divide it into two pieces, one out of the two parts is 1/2. But if we divide those halves in half, multiplying just the number of pieces, then we come to fourths, and you can see it takes 1, 2, 3, 4 fourths to make a whole bag of chocolate chips. But these 2/4 are a different way of writing 1/2. And if we took those fourths and we drew lines here into the middle of all of them, we would wind out with 8ths. That's what we would have. And 4/8 equals 2/4, which equal 1/2. The amount stays the same, but the number of pieces changes. Another way of thinking about halves especially is if we look at these fractions, 2 is half of 4. 4 is half of 8. And we can even say that 1 is half of 2. So those mathematical relationships you have been building all your life, they will come to play with this, and that's good. Because fractions get super weird, because they're dealing with pieces and parts. Just like when we were doing decimals and money, just all those decimals were just kind of weird. Well, this gets even worse, trust me. So equivalent fractions are two or more fractions that name the same part of a whole, but with different denominators. Now, you know Math in Focus, they do love these number lines. So they've got some number lines here for us to use to find those same equivalent fractions. And you can see, here's the half, one jump. Now on this number line, they divide it up into fourths, 1/4, 2/4, 3/4, and we can see it will take those 2/4 to get to the middle, that halfway point. And then also we have this one divided into 8ths, and you can see that here's 0, and here's 1, the whole thing. They didn't write it on there, but I could show the whole thing there, that 1, as 8/8. And they didn't put it on the fourths, but I could show the whole 1 as 4/4, because that would be a whole thing in that case. And they didn't write it here either, but I could say that that 1 is the same as 2/2. It's going to be important coming up. Now, when we multiply fractions, we increase the number of pieces or cuts in the amount, never the amount of stuff we have. And we can find equivalent fractions using multiplication. What we'll be doing is multiplying the number of pieces in each fraction by a variation of 1 written in fraction form. And you saw this on this page right here. I just showed that to you, that 1 is equal to any fraction as long as the numerator is equal to the denominator. So this is 1, and this is 1, and this is 1, expressed as a fraction. And so let's try to find some equivalent fractions here. We've got 1/7, and I like using the sevenths whenever the book gives them to me because we don't use sevenths a lot, so why not? And also we get, pay attention. We're going to be using our times 7 facts a whole lot with this one, so just be ready. Okay. So you can see here that here's 2/2, here's 3/3, here's 4/4, here's 6/6. And if I were to call this a number line, right there would be 7/7. So this one is split up into 7 parts, this strip of paper, and only this one is 1/7. But look, do you see how they just multiplied the number of pieces by cutting each piece in half? Okay, that's another thing that really wigs me out about fractions. You divide the fractional parts to multiply the fractions. Does anybody else's brain really hurt with that? I've been fighting it for years teaching 4th grade. That's just really hard to think about. Now here you can see they've got, we're going to multiply, since we cut every single piece in the denominator in half, we're going to do the same thing to the numerator. Because if I change the size of the pieces, I have to change what's in the numerator as well. So they're saying that 7 times 2 is 14, and 1 times 2 is 2. You can see in the model over here that 2/14 is equal to 1/7. Now, I wanted to show it by multiplying this way. Instead of having us float up in the air, I am multiplying 1/7 by 1. That reminds me I'm not getting any more stuff. I'm literally multiplying my pieces by cutting things. Be a ninja. Channel your inner ninja knife. Okay, so here's 2/2, which is equal to 1, but as a fraction. And so you can see that 1 times 2 is 2, and 7 times 2 is 14 in the denominator. And then I look over here and whoops-a-daisies, I'm going to go grab another color up here because I can. They took this whole thing and they divided this into, each 1/7 was divided into 3 parts. Now, yes, they cut it, but they're multiplying pieces. So if every one of these pieces is 3, well, 7 times 3 is 21. They've got that in the denominator there, and that means every one of these little guys right there is a 21st. That's how we'd say that. But just the ones in this little piece, that's 1/7, well, 1 right here times 3 equals 3. So we would have 3 21sts. And this is how I did it over here. You can see I just used the fraction and just multiplied it by 1. I'm not getting more stuff. 1 times anything is itself. But 1/7 times 3/3 is 3 21sts, not because we have less, just because we have more pieces. So down here we can say that 1/7 is equal to 2/14, which is also equal to 3 21sts. Ooh, Miss Foster, could we keep going? Oh yes, we could, because we could multiply 1/7 times 4/4. 1 times 4 is 4 on top. 7 times 4 is 28. You got it. I could multiply 1/7 by 5/5. 1 times 5 is 5. 7 times 5 is 35. That's right. And last one, I'm going to make it super hard just for fun. 8ths. Yes, we will multiply 1/7 times 8/8. No different amount of stuff, just teeny tiny pieces. Okay, so 1 times 8 is 8 in the numerator, and 7 times 8 is 56ths. Wow. That would be a tiny piece. Oh my goodness. Let's move on. Now, of course, if we can multiply, we can also divide. And again, this is where math gets so literally magical for me. We're going to do magic with math. Most of the time, math is not magical. But this is one time where I think it is. Using division, find a common factor for the numerator and the denominator, and then divide by a variation of 1 written in fraction form. What is she talking about? Well, over here they have 6/12. I'm going to write it here just a little bit bigger because it's going to make me happy. What is a common factor between 6 and 12? Well, they're both even, so I know that they have a common factor as 2. I'm going to divide them by 1, written again as 2/2. And 6 divided by 2 in the numerator is 3. And 12 divided by 2 is 6. And they've shown that to you over here. What they're literally doing there is uncutting it. That's why I think this is magical. They're taking out this cut, and this cut, and this cut, and they have to do it for the denominator too. Because remember, fractions always have equal parts. Super important, equal parts. I think you already know that, but just in case, now we've reviewed. So if I take the cuts out for the numerator, I've got to take them out for the denominator. I hope that makes sense. Now, they kept going though. Let me see, 6/12. What other factor do 6 and 12 share? Well, 6 is 2 times 3, and 12 is 3 times 4. So I think I could also divide 6/12 by 3/3. Now, any number divided by 1 is itself, so I'm not getting more stuff here. And you can see in this picture, it's always the same amount of stuff, isn't it? 6 divided by 3 is 2, and 12 divided by 3 is 4. Wait a minute. I think I can simplify this even more. Before we do that, do you see the 2/4 right here? Do you see how 6/12 is equal to 3/6, which is equal to 2/4? But wait, there's more. Uh-oh, did I need to scroll down? Nope, I just didn't even put up here. So I made a mistake. That's okay. Can we divide it more? Yes, and here's why we want to do that. Because if we divide it even more, we will find its simplest form. Now, the simplest form of a fraction is found when the numerator and the denominator share only 1 as a factor. And when I look at 2/4, I think, they still share another factor. So now I am going to divide 2/4 by 2/2. Yeah, so here we go. 2/2, or 2/4, I'm sorry, divided by 2/2 equals 1/2. And then that makes me wonder, did I have to go through all these steps? I did if I wanted to find equivalent fractions. But you'll do a lot more of this next year in 4th grade, but let's start thinking about it now. In 4th grade, we will talk about understanding relationships between numbers and understanding their greatest, largest common factor. When I look here at 6/12, yes, they share 2. Yes, they share 3, but you know what they really share is 6. We could have gotten to 1/2 in one step because we could have said, oh my goodness, 6/12, they both share 6 as a common factor, so we're going to divide by 6/6. And 6 divided by 6 is 1, and 12 divided by 6 is 2, and we'd get down to 1/2. Cool. Simplest form turns out to be super important. Every single teacher you ever have is going to want you to get things to their simplest forms. Let's take a look down here at the finding equivalent fractions of 4/12. And here you can see they're dividing 4/12 by 2/2. 4 divided by 2 equals 2, and 12 divided by 2 equals 6. So 2/6 are equal to 4/2. Here we're going to divide by their common factor 4. 4 divided by 4 is 1. 12 divided by 4, we just practiced this one, is, whoa, a mistake. Sorry about that, guys, that's 3. I don't know what I was writing. So we can see that 4/12 is equal to 2/6, and 4/12 is also equal to 1/3. What is the simplest form? Well, 2 and 6, they still share a common factor of 2. But 1 and 3, they share no common factor except 1. So we would call 1/3 the simplest form. We can't find any fractional form of this that has larger pieces. Yeah, and larger pieces are just, wouldn't you want a larger piece of cake instead of like a whole bunch of teeny tiny little bites? I mean, let's look at these fraction bars that we sent you home with. You know, if this were half the pie, would you want this, or would you like it mashed up into all these little pieces? I think you would just want to come get the biggest piece of pie that you could. Pie's delicious. Okay, so in this lesson, we've talked about finding equivalent fractions. It's a super important math skill. It will serve you well. And really press into it as you do your workbook pages on this. Equivalent fractions show the same amount as each other, but with differently sized pieces. And remember, some of the information that a denominator gives us is it tells us the size of the pieces. And you're going to want to do that. You're going to want to understand that, because you can see here are a whole bunch of equivalent fractions to 1/2. And you can literally see with these fraction bars that those pieces get smaller and smaller, don't they? We can find equivalent fractions by multiplying or dividing one fraction by a variation of 1 written in fraction form, such as 2/2, 3/3, 4/4, 6/6. And so if I started out with 4/8 down here, well, I could divide them both by 4 and get straight to 1/2, right? Or I could have divided them by 2 and wound up with 2/4, and then divided those again and gotten down to 1/2. But if I wanted to, I could also take this 1/2 and multiply the 1 times 3 and the 2 times 3 and get 6ths. 3 of them there. Oh my goodness, fractions make our heads spin. It's so much fun. Now, I'm giving you a lot of workbook pages here because I just love how the workbook takes you tiny step by tiny step by tiny step and gives you lots of different practice looking at equivalent fractions in different applications. So we've got 7 pages here. Please grade each page using the answer key that I am sending you on Seesaw. You should find it there. If you don't, get with your mom or dad right now, have them send me an email or mention it to your teacher in morning meeting and they can send me an email. I am truly trying so hard to get this to you. If you get one wrong, go back, don't move on, figure out what your mistake is and learn, and please write that. Please do grade them in color, so when you turn it into me on Seesaw, I know that it's good to go. Then I can approve them. If you get lost, if you get